This is Math 1314, Chapter 1, Section 4, Solving Quadratic and Cubic Equations. I'm David Dipple from Lone Star College, Montgomery. We're going to be looking at equations with x squared, which are quadratics. There's a lot of different methods, including factoring, taking square roots, quadratic formula, completing the square, finding imaginary solutions, the discriminant, solving by graphing, and finding equations given a set of solutions. Solving by factoring involves just that, factoring x squared, setting up two sets of parentheses. Because there's a square, there's always going to be two factors. So you factor x squared and you factor 27. X squared is going to be x times x to make 27. You can try 27 in 1, but that doesn't add up to 6. You want factors that add up, in this case, to positive 6. So I chose 9 and 3, because 9 times 3 makes 27 negative, and 9 minus 3 makes the middle 6. Then once you've factored it, you take the first factor, make it equal to 0, because anytime two things equal 0, they independently must equal 0. So x plus 9 equals 0, x minus 3 equals 0. When you subtract 9, you get negative 9. Add 3, you get positive 3. Now, when you're at this point, you can't just take the opposite of the positive 9. It gives you the answer. Opposite minus 3 gives you positive 3. Anytime you have parentheses, you can just take opposites, and that will give you the answers. Okay, factoring then leads to isolating a square. If you have a perfect square that you can isolate, try doing that by, in this case, moving the 10 with addition. By adding 10 gives you 27, or 17 rather. Nope, that's not right. Yes, that is right, sorry. I think it was double twice there. 10 and 7 is 17. Now you move the square by taking the square root. And make sure you put a plus and a minus, because when you square root a square, you get two possible answers. Then we're going to move our 4 by subtracting 4. And you get negative 4 plus or minus the square root of 17. Okay, quadratic formula. This is something you're going to need to memorize. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac, the whole thing all the way up to the in front of the b there, divided by 2a. And this comes from a is the coefficient of x squared, b is the coefficient of x, and c is the remaining constant. For example, if you have 2x squared minus 3x minus 5, your a will be the front 2, that goes here and here. In front of x is your b, so that's minus 3, so it's minus 3 squared. And your minus 5 is your c, goes right here where the c is. Or, in other words, negative 3, because that's b, negative 3 squared, that's b, minus 4, then a, which is 2, c, which is negative 5, 2a, which is 2. Now I combine the inside, and when you do, 3 squared is 9, 4 times 2 is 8, times 5 is 40, and two negatives make a positive, so this is 49. 4 in the bottom, two negatives make a positive 3. 3 plus or minus the square root of 49 divided by 4. Now the square root of 49 is 7. That makes 3 plus 7. That's the plus part, and then the minus, 3 minus 7. And then you can simplify those. 3 plus 7 is 10 fourths, makes 5 halves. 3 minus 7 is negative 4, divided by 4 is negative 1. Now, completing the square is another way to solve things. First thing you need to do is have a 1 coefficient right here. If the leading coefficient is not 1, you must divide by whatever's there. It's already 1, so we don't have to divide. You would divide the x squared coefficient, the 10, the 3, and the 7. Everything gets divided by 1 in this case, but whatever's in front of x squared. That's the first step. Then we move everything to the right, the constants. But I leave a space. Don't close in that space. So you have x squared minus 10x. The 3 moved over makes 4. Now I'm going to complete the square in a perfect square by taking 10, cut it in half, and square it. So negative 10, cut it in half, square it. That's 5 squared is 25. So I put a 25 on the left and a 25 on the right. And then I factor. This is a perfect square. We completed the square. That's why it's called completing the square, because 10x squared minus, x squared minus 10x plus 25 is a perfect square. That's x minus 5 squared. You can just take the x, take the minus from the middle, square root makes 5. And 4 plus 25 is 29. Now we're into that square thing, so to get rid of the square, we take the square root. Plus or minus the square root of 29. And again, the square root cancels with the square. And then you move the 5. So it's positive 5 when you move it, plus or minus the square root of 29. So that's completing the square. Now, imaginary solutions. Sometimes you can get equations that will come out to have an imaginary solutions. You can solve them by quadratic formula, completing the square. Those are the main two ways to do it. I'm going to use quadratic formula in this case. We identify our ABC. A is 2, B is 1, and C is 7. So we plug those in, and it's minus 1, because that's our B, plus or minus B squared. 4 times A is 2 times C is 7 over 2 times A is 2. Now when you simplify that, you get negative 1. 4 times 2 is 8 times 7 is 56. Minus 1 is negative 55. So it's negative 1 plus or minus negative 55 over 4. This negative can come out as the letter I. So it's negative 1 plus or minus I squared of 55 divided by 4. So we have an imaginary solution, in this case 2 of them. Now the discriminant is something that gives you more information. B squared minus 4AC, that's one under the radical. If it is bigger than 0, okay, then you have 2 solutions, because under a radical gives you a plus and a minus, and they're going to be irrational. B squared minus 4AC, if it's a perfect square, you're going to have 2 real solutions, because they're going to be real numbers, because you can square root perfect squares. They're just real numbers. If they're equal to 0, you're going to add and subtract nothing, so you're just going to get one answer. And if it's less than 0, because remember this comes under the radical. If you have a under the radical less than 0, it's imaginary. So you have 2 imaginaries or 2 complex solutions. So that's what the discriminant tells you. Now if you have 3x squared minus 10 equals 0, your discriminant, which is b squared, there's no b, minus 4ac, turns out to be 0 squared, because there's nothing there, minus 4 times 3 times negative 10. When you do that, you get a positive answer. It happens to be 120. We don't really need the numerical value. If you look at our table, you just needed positive, negative, 0, okay, or perfect square. So in this case, it's positive, so you get 2 irrationals. Something like x squared minus x plus 2, find the discriminant. Again, b squared, negative 1 squared, minus 4 times 1 times 2. This turns out to be negative. Negative means you have 2 complex, or 2 imaginary. And you can look at in my math lab, sometimes it'll use complex, sometimes they'll use imaginary. X squared minus 2x plus 1, do the b squared minus 4ac, gives you negative 2 squared, minus 4 times 1 times 1. That gives you 0. And since it's 0, that was down at the bottom of our table, that's one rational solution. Okay, now we're going to reverse the process. Suppose we have x equals 2 or x equals negative 5. If you'll take this 2 and move it across the equal sign, take that 5, move it over by the x, you'll get your 2 factors. x minus 2, moving the 5, x plus 5. Then if you multiply x times x, you get x squared, x times 5, 2 times x, and 2 times 5. Then it'll turn it back into the formula that you would have started with in the other format. X times x is x squared, x times 5, 2 times x, and 2 times 5. When you clean that up, you get x squared. 5 minus 2 is 3x minus 10. And that is the equation given what we started with was two solutions. We turned them into factors, multiplied it out. Cubic equations. Whenever you have perfect cubes, you can either have the sum or difference of cubes, or you can group, and we'll deal with that later, and or you can use a graphing calculator. If you just type your equation in and graph it, the place that it touches the x-axis, those are your zeros. And that is everything in section 4, quadratic equations. Really quick, the pattern for cubes, if you have two cubes, you just drop the cubes, then you square it, take the opposite sign, you put the A and B together, and then you square the second one. And that's the pattern for cubes.